So, you there in the back of the room, Ashlyn, um, it says determine whether each binomial is a factor of all that. Yes. That means divide it and say if it goes in there, if the remainder is 0, it goes in there evenly, then it is a factor. If there's a remainder, then it's not a factor. Okay, do you want me to go through that with you, or can you take it from there? Okay. Good little review since I haven't seen you guys for a while. Uh-huh. All right, so to figure this out, the first thing I have to do is divide the first term here. Yeah, by the first term there. Woo! So if I go x cubed divided by x, what do you get? X squared. So that tells me that x squared goes right here. Then since I know that that's x squared, what do I do now? Right, I multiply, I have to distribute this to both of these. So I go x squared times x is x cubed. And yep, and then x squared times 1 is 1x squared. Wow. Yeah, no kidding. You go, girl. So then you go first term here, 3x squared, divided by first term here, which is x. What's 3x squared divided by x? 3x. The 3 stays the same, but this x cancels one of those x, so the x squared becomes just an x. Okay. Now what? Okay, so 3x times x is 3x squared, and then 3x times 1 is 3x. And then remember, we are subtracting, so the 3x squareds cancel, but it's going to be negative 2x. X minus 3x is negative 2x. Bring down the negative 6, and we'll go around the horn one more time. What is negative 2x divided by x? Negative 2. So if I distribute here, I get negative 2x minus 2. We can stop there because we know there's going to be a remainder, but let's just practice this last step because you guys, this is the hard part. Negative 6 minus negative 2, because it's negative 6 minus negative 2, right. So it's negative because you're subtracting the negative, so you're really adding, so it's negative 6. Okay, so that's negative 4. But again, the important part for this problem is we're just trying to determine whether it's a factor or not. So since there is a remainder, the answer is no. No. Okay, good to hear. The remainder is negative 4, and since there is a remainder, it is not a factor. The answer is no. It has to all cancel out. Yeah, I'll do 16 just a second. Yeah. 20? Uh-huh. I'm going to jump back and do 16 real quick first, okay? What? 15 also? Uh-huh. All right, Peyton. What goes on top? What goes on top? Then we have to what? That's what I'm doing. So what's x cubed divided by x? Okay, so I put an x squared up there, and then when I multiply those together, what do I get? I get, what's x squared times x? Cubed. And then I have to go x squared times negative 4. What's x squared times negative 4? Negative 4x squared, okay? So when I do that, I'm hoping that this is what you're asking me about. Oh, go ahead. It does do something because every time I put a number up here, I do have to multiply it by the negative 4 in that next step, but it just doesn't do anything in determining what that number is going to be, okay? All right, so the tricky part of this one, which is hopefully why you guys asked for it, is because this is x's and this is x squareds, right? So you can do it, but you can't do this with this. So you have to sort of pretend that there is a 0x squared right there, and then minus 13x and minus 12, okay? So then it would be 4x squared, yeah, because if you go 0x squared minus negative 4x squared, minus a negative is really a positive, okay? So if there's a missing exponent, like if it skips from x to the third down to x, you should really put in that space a 0, whatever it is that's missing, so that this next part is a little bit easier, okay? All right, then I'm going to bring down the negative 13x, and I'm going to go around again. Sophie, what do I do next? Right, so 4x squared divided by x is 4x, so that goes on top, okay? Now what? So 4x times x is 4x squared, right? And then 4x times negative 4 is? No, ma'am. 4x times negative 4. Negative 16x. 4 times 4 is 16. Okay. All right, and then I'm sticking on you. These cancel. What's negative 13x minus negative 16x? That's why it's called long division. 3. Okay, so this is going to be 3x. Okay. All right, then I bring down the negative 12, and I go around one more time. Aww. Callista, what is 3x divided by x? 3. Yep, the x's cancel, so that gives me 3. So I'm going to write that up here. And then I'm going to take these two things and multiply them by 3. So 3 times x is 3x. And then 3 times negative 4 is negative 12. And then since those things are the same, they'll all cancel out. I'll get 0. So I have no remainder. So that's the answer, yeah. What's that? Yeah, in classroom codes. Yep. So I put the videos on YouTube, and then I put the YouTube link on Google. L. Aldrich. 53 subscribers. What? They can't really hear. This does not pick up your voices very well. You mostly, yeah, you mostly just hear me. Which we won't try that. Okay, Chris, you had asked for number 15. Is that true? Oh, Jessica, that's right. You asked for number 15. Okay. All right. So what do I start with up there? Yep, x squared divided by x, which is x. And then if I multiply these back through by plus, and then remember we're subtracting. So I'm going to go negative 7x minus 3x gives me negative 10x. Okay? Plus 10. Then what do I have to multiply x by to get, or so I'm sorry, what's negative 10x divided by x? Multiply. So what's my remainder? Good. That's it. Nope, that's good. Yeah. No, this isn't asking you. The first ones weren't asking if it is a factor. They were just saying just divide it. Okay. Emma, did you ask for 20? No. Did somebody ask for 20? No. Yes? Okay. I'll do 20. Yes, and our next quiz is on Thursday. Chris, what's x cubed divided by x? Uh-huh. Multiply those back out. X cubed. Okay. No, because remember I'm subtracting. So that basically, right. And then bring down the x and go again. Uh-huh. Good. Whoops. Uh-huh. What? Nice. And then finally, it'd be positive 60. Yeah. Okay. All right. Well, you guys. Okay. Today's lesson is everything you want in a math lesson. It is relatively short. It is super easy. Okay. But it is also really useful. Okay. Well, sorry. Can't give you that last part. All right. So we're going to learn today how to do basically the same thing that we were doing on Thursday, the long division, using a different process called synthetic division. So a couple of notes. I talked to Ashlyn. She's a little nervous because she, as you guys probably saw at the beginning of class, she totally gets the long division. Okay? You can always do it that way if you want. So if I do this and you're like, nah, then you can just stick with the regular old polynomial long division. And then that's the second thing I wanted to say. Thank you for bringing that up. The reason I have to teach both is because even though this is easy and fast and effective, you can't always use it. Okay? You can use it 95% of the time, but you can use long division always. Yeah. So you learn the long division because you can always use it, and then we learn the shortcut because most of the time you can use this instead. Okay? All right, so here we go. We're going to do, like I said, basically the same stuff. So in this case, we're going to start by going x plus 2, and we're going to divide that into x cubed minus 14x squared plus 51x minus 54. But instead of doing it in the long division way, we are going to do it using synthetic division. So the only reason why I'm writing this up here is so that you can see how I get from that to the way that I'm going to write it synthetically. Callista. Yeah. Are you doing a bird box challenge? Is that basically what's happening right now? Did you watch the movie? No. Of course, yes. I don't really like horror movies, no. I don't like scary movies. It is definitely a scary movie. When you take the blindfold off, you see like your worst fear or whatever come to life. That's definitely scary, yeah. What's that? Yeah, that's a really good idea. All right, so here's how synthetic division goes. We're gonna start by making a little box right here, and in that box, I am going to put the number that makes this 0. Okay, so what number makes x plus 2 equal to 0? Negative 2, and that might seem kind of strange to you, but on the other hand, we've done that a lot when we have factored polynomials into x plus 5 times x minus 4 equals 0, for example. And then you have to find the answer. The answers are negative 5 and 4. Yeah, so when we're solving these, we do the opposite. So the same thing is true here. I'm going to take the x plus 2 and I'm going to basically do the opposite, okay? Then what makes this easier than doing regular long division is instead of writing out the whole problem, I'm just going to write out the numbers, not the variables. So when this says 1x cubed, I'm just going to write the 1. And this says negative 14x squared, I'm just going to write the negative 14. Okay? And then when I write 51, instead of writing 51x, I'm going to write 51. And then instead of writing the negative 54 by itself, I'm just going to write negative 54. Okay? Sydney? Oh, this was just an example of something we've done before. Okay? Not related. Callista? I mean, Batman. What? Uh-huh. It's just, I just call that a little box. I just put that number in a box. I'll show you in just a second. Because we want to put in there what makes that equal to 0. Okay? All right, here we go. Are you ready? Are you going to say something negative? Are you making a comment? No, I just don't like it. I'm confused. Okay. So the first thing that we do to start the process of synthetic division is you bring the first number down. So this is a 1, so I'm going to put the 1 right there. Okay? Then all you have to do to finish this problem is multiply and then add, and then multiply and then add, and then multiply and then add. Okay? So to start with, you win. So to start with, negative 2 times 1 is negative 2. And then I add those together and I get negative 16. And you don't have to do that weird thing with the long division where you're actually subtracting, so switch the sign, all that kind of stuff. You just add them together. Okay? The 1 is the first number. I just brought that down. Okay? The negative 2 right here, or the negative 2 right here? This one? Okay, this one comes from what makes this be 0. So negative 2 plus 2 is 0. And then this one right here is because I went negative 2 times 1 is negative 2. I'm just going to multiply and then add, and then multiply and then add. Okay? So now if I go negative 2 times negative 16, what do I get? 32. And then if I add those together, I get, if I add these together, I get, 83. Okay? And then negative 2 times 83 is negative 166. And then if I add those together, I get negative 220. Okay? Now, you're looking at this and you're looking at those numbers and it looks like complete nonsense. You have no idea what's going on and how do we even see an answer in there. Well, remember what we did to start with is we just wrote down the numbers and not the variables. Now we're going to put the variables back. Okay? Since we started with x cubed, this answer is going to go down by 1 power always. So if I started with x to the 5th, it would just go down by 1. So instead of this being 1x cubed, this is 1x squared. And then you just go down by 1s from there. Minus 16x plus 83 with a remainder of negative 220. Okay? So that is the answer to this thing divided by this thing. So we're just able to get it a lot more quickly without doing as complex math using what's called synthetic division. Vili? Okay, good question. It will not work when we're dividing by something that has an exponent higher than 1. So if we were dividing by x squared plus 2, we have to use regular old long division. Okay? Peyton? Okay, so anytime the number's down here, you're multiplying. These are times. And then anytime the numbers are here, you add. Does that help? So I took this number and I went negative 2 times 1 and got negative 2. And then I added those together. And then I went negative 2 times negative 16 and got 32. And then, so yeah, yeah, right. And you're always going back to the negative 2. Okay, Abby. Because this is 100 times easier, and I know as I'm going through this problem, and like 5 of 6 of you guys are panicking and saying, "No, I'm lost." I remember I recalled fondly in my head back to September when we were first getting to know each other, and that every day was like that. Like I would come up here and start teaching, and then immediately like 15 of you would be like, no, 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 I don't understand. What are you doing? I'm totally lost. So we're making progress, which is good because only like 4 or 5 of you completely panicked. But just stay with it. It's easier, okay? And here is, I guess, the real answer to your question, okay? All right? We are going to reach a point where we're starting with this. This is not going to happen in this class, but we're starting with that. And we're going to try and factor it in if we have no idea how to do it, okay? And so the way that we're going to do that is we're just going to guess what numbers go here, and we're going to do this process again and again and again and again until we get 0 as an answer, and then we'll know, okay? That's next year. There's a way to make the guesses easier than just totally random numbers, but at some point we will kind of have to use this. So I can't remember if it was in this class or first period, but I accidentally gave you some problems that had x cubed and then x squared and x and then a number, and you couldn't factor anything out. And somebody, I feel like, said, how do we factor this? This is how, okay, by using this method. Mr. T? Okay, this one right here came from the 1x cubed, okay? And then the way you always start synthetic division is whatever that number is, you take it and you bring it straight down, okay? Because you have to have a number to start with, all right? Okay, so let's try another one. This time let's go x minus 7 divided into this. So I'm going to start by making a box. In this case, since I'm dividing by x minus 7, what goes into the box? 7. And then, like I said, I'm going to just rewrite the polynomial, but instead of writing all of the variables, I'm just going to write the numbers, okay? So how many, this is important, how many x cubes do I have? 1. So I'm going to start with a 1 again. The reason why this is important, Danica and Alexandria, that you don't miss this little subtle piece is how many x squareds do I have? 0. So I do have to put a 0 there to hold the place for that, which is a lot like that problem that we did from your assignment from Thursday where you're doing this with regular long division and there were no x squareds and you had to put a 0 in there, okay? How many x's do I have? Negative 57, and then I have plain old 56, okay? So that's my setup. I'm just basically writing the division problem without any of the x's. And then all I have to do from here is multiply and add and multiply and add. But like Sydney was asking, I need a starting point. This first number is going to be my starting point. So I just bring that down right there. Okay? So now I multiply those two numbers. 7 times 1 is 7. Add these together and get 7. 7 times 7 is 49. Add those together and get negative 8. 7 times negative 8 is negative 56. Add those together and get 0. So again, like I said, some of you were in so this is a factor. Some of you were in quite the state of panic in the beginning. This to me is a super, super simple process, okay? I didn't have to think about when you divide x cubed by x squared, do I cancel the thingies or what happens to the exponent and all that kind of stuff. Yeah. And then I just add those together and that gave me 7, and then 7 times 7 is 49. Add those. Okay? All right, so we started with an x cubed, so this is going to be, yep, good, this is going to be an x squared plus 7x minus 8. This time the remainder is 0, so that means that this is a factor of this. This is also a factor of that. Those two things multiply together to equal that. Yeah. No, because I don't know if you noticed this, but every time we did long division, if I start with an x cubed, then it's going to drop down 1 and be an x squared, okay? Okay, so that's synthetic division. Like I said, you can do it the old way if you want to, but I would encourage you to try to do this way instead. Okay? All right, there's one more thing in here that I'm going to show you. It's just basically a different use for synthetic division. It's called the remainder theorem. This is not a thing that I or my students usually remember. And again, you don't have to do this way either. But just for curiosity, will somebody take out a calculator and plug in -2 for the x's in this problem? Or let's just do that together. So if I plug in -2 here, what's -2 cubed? -8. And then -2 squared is 4. 4 times -14 is -56. Okay? Nope. Then -2 times, well, you should know this already, but -2 times 51 is -102. And then I have a plain old -54. If I do all that on a calculator, guess what I get? -220, which not coincidentally is the same as the remainder, okay? So what the remainder theorem is saying is, if you are asked to plug in a value of x into a polynomial, instead of doing it this long way, you can just use synthetic division, and whatever the last number you get is, that's what you would get if you plug that number in, okay? So for example, if we wanted to know what we would get if we plugged 3 into this polynomial, you could go 3 to the 5th minus 2 times 3 cubed minus 3 squared plus 2 and get the answer that way. And that's totally fine. That's what we've been doing, and that's probably what you will be doing in the future. But what the remainder theorem tells us is, if I don't want to do all that, maybe I don't have a calculator because my math teacher is being mean, I can just use synthetic division instead, and that makes the math a lot easier. And then I can figure out that the answer is going to be 182, okay? In other words, what I just figured out is that 3 to the 5th minus 2 times 3 cubed minus 3 squared plus 2, if I plug that in, I would get 182 as an answer, okay? What's that? P is what we named the polynomial, okay? And then the 3 is just, since we replaced this x with a 3, we have to replace all those x's with a 3 also, okay? So if you come across these problems, do it using, or you can just plug it in like this and use your calculator and you'll be fine. But it's just another way that that is useful, okay? Yeah, like, are you asking if we will, yeah, most people turned them in yesterday. I'll take that from you in a second. Are you saying we're not going to have a quiz tomorrow? Right. So tomorrow we'll go through your questions from this assignment, and then there's a mid-chapter review assignment that we'll work through together, and then Thursday we'll have a quiz. Yeah.
And that's it for our end of semester.
That's it. End of semester. That's it.
No
No big test. No final. No. Yeah.
final at the end of the year.
Possibly.